Hello everyone, today we're going to learn a new model or software in another language. This software is very practical. You might have learned in other classes that you have taken, maybe water quality, water chemistry, that, or maybe in environmental engineering. So because it has application in many different fields. What it calls, maybe you have heard about it, Visual MINTEQ, right? This is a great software, we're gonna use it. So it has application in many different fields: environmental chemistry, geochemistry, chemistry, environmental engineering. So it has many applications that you can use it. So base of this software, so what's the base? Base of this software is for what? A speciation, right? A speciation. So a speciation of the what? For example, in AQ space, we have a lot of different compounds. Assuming we have carbonic acid, H2CO3. Right? H2CO3, right? Carbonic acid. We have two hydrogen, right? So this hydrogen subject to dissociation. In the first step, step 1, we will lose one hydrogen, right? We will have bicarbonate acid, CO3, 1 minus, plus 1 hydrogen ions. What about the next step, right? These are reversible, right? Reversible. The next steps, we will have carbonate, CO3, 2 minus plus 2H plus, right? So these are reversible. Let's write here are reversible. Why it is reversible? You can see here, right? We have hydrogen. So when we have hydrogen ion, so it means pH dependent. In water chemistry, in acid-base dissociation, we have learned, what is that? The concept of pKa, right? pKa. Do you remember what was the pKa? Do you remember what was the pKa? pKa minus log of K. So it means the pH at which the concentrations of acid become half of its dissociation. Acid goes half of dissociate form. So this software is mainly based on dissociations, right? So when we talk about dissociation, imagine, for example, we have this equation, right? We are not talking about the kinetic. When we say, okay, no kinetic, what that means, no kinetics. So we are not considering the time, right? Time. So we do not consider the time. But we are considering equilibrium. So equilibrium. Right? In this concept, we are considering equilibrium. What will drive the equilibrium? Thermodynamic condition, right? Thermodynamic condition. So for us, thermodynamic condition is very important, and because this is not a command-based model. Like many other models, or some of them we work recently with Colab. We have to write a command for them, right? But this one does not need a command. Not need command. So then it would be easy friendly use. Friendly use software. So what do we need if we don't need a command, right? This is equilibrium, so it means we have to give a data. Input data. We need the input data to have output. For example, we have to give the pH, we have to give the concentration to have calculations of bioavailability of the metals, or the sorptions, or complexations. For example, what question we can solve using Visual MINTEQ, right? Questions we can solve. Question to solve. For example, how much lime adding to water to remove metal, as a pollutant, metal, right? There are many other questions, like how much phosphate is bioavailable in soil? How much phosphate is bioavailable in soil? Or how does pH change affect metal mobility? Because it's based on a dissociation, right? How pH can impact metal mobility, and many more. So we can use it for many purposes, because let's see if I have a better marker, because it will calculate for us. It calculates chemical dissociation or speciation. Speciation, solubility, and precipitation. So these are related to each other, right? Chemical speciation, we want to see what metals are available, what complexes would be unavailable or precipitate. And the sorption on surfaces. Sorption on surfaces. Surfaces like a clay, for example. Like a clay or oxide. And also complexation with the ligands, right? Complexation with ligands. So it can calculate chemical speciation, solubility, sorption on surfaces, and complexation with different ligands. We will input the data. It has a very big thermodynamic database itself, and it will calculate based on input data and thermodynamic condition. It will calculate for us the availability of metals. So the output would be, the output for this model would be a speciation distribution of free ion, complexation, precipitation, and so data. So very easy to use, and in the next step I will show you how to install it. Mainly, as far as I know, it was not working last time with Mac. It was working only with Windows, but maybe it also works now with Mac. You have to figure out. First, you have to see how is your system, is it 32 or 64 to install this software. Very easy software to install, and it's for free. That's important. It is for free. There is some parameter like a pressure you can give, pH, and the concentration of any other ions that I will give you example to solve and get the data. You can extract the data by CBRs or different Excel type form, and you can plot them. What else about this software? And I will explain to you later when we install it. Very easy to use. So today we want to learn how to install this software if you do not have it in your laptop. This software called Visual MINTEQ. Visual MINTEQ. Download. It's easy to download it, but first you have to know if your computer is 62 or 64. It's 64 or 32. So here we have, you can install in OneDrive or you can install in Google Drive. It's very, very easy to download it. But how you know what is your computer, 32, 64 or 32? Let's see. We can figure out here. Okay, here you just type system and bar by search, then you can find here. It's written somewhere, should be somewhere, you have to find out here. This is a 64, system type 64. For us, it's 64. For me, it's 64. For you, I don't know. You have to check it out. But when you download it, this platform will pop up. So, MINTEQ. I already installed it. Make it easy. So it has a very easy platform. So we have in the menu bar on the top, you will see different parameters. You can work on that, you can play with that, you can add different parameters, specify P and EH, solid phase and exclude species, adsorption, gases, redox, multi-problem suite, database management. But we do not need to work with those. As I give you instruction in attachment, you have to adjust the pH and the fixed pH, and you have to adjust the concentration milligram per liter. It's up to you what concentration you want to use, but I suggest to use milligram per liter. You can also change the temperature. I told you this is based on thermodynamic base. If you change the temperature, you will have different result. How you can add the component. Here, select from the list, right? Here you can see we have variety of components. For example, we want to add chrome 3 here. Chrome 3 and 0.5 milligram per liter. So we would do add to the list. The value of 0 is not allowed in this box. So it is not 0. Then let's add copper. 2 milligram per liter. Add to the list. It's not allowed in this box. No species added. Let's see. View edit list. It did not add to the list, and the other screen will start. Okay, now it's adding, right? Added to the list. Let me see. And again, let's add gold, add to the list. We didn't get the error, we just added to the list. Then we are adding another one, copper, put 5, add to the list. Then we put another metal, 3, add to the list. So you can also see view edit list. Another window will pop up and you can see what you have added, right? Then back to the main menu. Then you can run. So it will run and tells you the date you have obtained. Okay. So in this screen you can see it has run. You can print to Excel, but you can see also speciation. I will give you instruction in the attachment. You can enter the data with the fixed pH and see what the speciation you will get. Back to the main menu. Very easy. You can also play with different parameters and see what result you will get based on experiment you are working on that. I have put for you instruction in the blackboard. You can follow up the instructions. Water quality practice assignments. There is an objective to introduce the student with equilibrium, chemical equilibrium modeling. The same thing we talked about it. So there is an instruction how to install it. Another easy example to follow. You will start a new project in Visual MINTEQ. The parameters you need to give to the system: temperature at 25 centigrade, pH at 6.5, ionic strength you can fix it at this number, and dissolve speciation, dissolve species in milligram per liter. Iron 3 is 1.5, aluminium 0.8, sulfate 50, calcium and magnesium 40 and 15. Then you will calculate. So you can click on the run and it will run for you. You have to check also the list that all have been already imported in the software. There are one more question to repeat the same thing at 3 different pH and compare the result. So you can follow this one and finish them by next week. So this would be like a small mini project for you to follow up and do it.